I have now recorded EMG signals from 7 different sites. Let's analyze them. I'm going to scroll through my table over here. Usually this table is much bigger, so you can see all the pairs listed. But because of the small video size, you cannot see all the entries. Now, by and large, the system will perform the analysis automatically. It really doesn't take that long. Many investigators actually measure the jitter as soon as they finish data acquisition. But for simplicity, I decided to collect the data first, and now I will analyze it. So let's start at the top. This was my pair number 1, so I'm going to click on this, and it puts me into the analysis screen. Let's look at the details. If I double click on top of the trace window, it maximizes it. So let's look at the all trace window at the top. These are the sweeps that we recorded. They are shown in superimpose mode. And we also have 2 windows that are overlaid. They look like the so-called TIE fighter from the Star Wars movie, or like an H symbol. And there are 2 of them, one in green and one in yellow. We call them the start and the stop windows. By default, the start window is placed at the trigger location. So this is where we were triggering the signals. The program automatically places the stop window where it finds a sharp time lock potentials. The system begins measuring time when the first potential crosses the start window, and it stops the clock when the signal crosses the yellow window. So this is how the interpotential interval is calculated. Note that we are using the so-called level-based interpotential analysis. I'm going to double click over here. We are back to our regular screen. The interpotential intervals are plotted sequentially in the graph in the bottom right corner. I'm going to maximize this. Each square represents one interpotential interval. Our x-axis is the sweep number. So in this case, we recorded about 150 sweeps. The system calculates the interpotential intervals, calculates its statistics, which is the mean value and standard deviation, and then draws a box which is 3 standard deviation above and below. Most biologic processes have a Gaussian distribution, and the 3 standard deviation band about mean contains the real data. So this is the first screening process in data analysis. Any data that fell outside the 3 standard deviation, you can see the blue square over here and over here, they are rejected automatically. The 3 standard deviation contains about 99% of the data. So out of 150, we expect to see 1 or 2 data points outside these limits, and this model fits perfectly. So I'm not concerned about rejecting 2 data points from analysis. Double click. I'm back to the routine mode. The traces that were acquired are shown in the top window. The traces that were analyzed for jitter are shown in the bottom window. What it means, going back to this window over here, these 2 traces corresponding to the blue squares are not used in analysis. They will not be shown in the bottom window, and this will become more obvious when we start analyzing other recordings. Let's look at the result table. I'm going to maximize this window. So this was my site number 1, recording number 1. So this is called pair 1.1. I recorded 150 discharges, and you may recall that we excluded 2 based on statistical principles. So the total number of sweeps included in analysis were 148. The jitter is calculated in 2 ways. We can calculate the so-called MCD, mean consecutive difference. We can also calculate the mean sorted difference, MSD. So in this case, the MCD is 11, MSD is 12. The system will automatically choose the smaller of these 2 values as the jitter, and therefore the jitter column indicates a value of 11 microseconds. The mean interpotential interval is 520 microseconds. and the firing rate of this motor unit on average was 8 Hz, and there was no blocking in this recording. So this is the way the data is presented in the results. Now, if for some reason, if you wanted to use MSD instead of MCD, we have a control at the bottom. See over here, MCD, MSD key. When I click on it, I'm going to manually override the selection. And now I have made the MSD to be the jitter. I can go back to the original setting by clicking on it again, and now I have selected MCD. So this is the way we can choose the MCD or the MSD value for jitter. This was a very nice clean recording. We have a normal jitter and no further editing is as such necessary.